In some bank exams, a 5 marks question is asked on probability where some data regarding a number of objects is given followed by 5 different questions based on probability. So let's discuss an example of a 5 marks question. The question here says a box contains 6 red, 4 blue, 2 green and 3 yellow marbles. So this is the data given regarding the number of objects. We have got different colored marbles here. 6 red marbles, 4 blue marbles, 2 green and 3 yellow marbles. So altogether we can see that we have 6 plus 4, 10 plus 2, 12 plus 3, 15 marbles. Now the first question here is, if 4 marbles are picked at random, what is the probability that 2 are blue, 1 is green and 1 is yellow? So very clearly, out of these total 15 marbles, we need to select 4 marbles. And what will be the probability that out of these 4 marbles, 2 are blue, 1 is green and 1 is yellow? Now as you can see here, we are trying to pick up the marbles at random. So this is a case of selection. We are only selecting the marbles and we are not arranging them. And selection is nothing but a combination. So we need to use the concept of combinations, that is NCR, to find out the required probability. We know that probability of any event can be taken as number of favorable outcomes divided by total number of outcomes. Now here the favorable outcome is that out of total 4, 2 have to be blue marbles, 1 should be a green marble and 1 has to be a yellow marble. So let us see what are the number of favorable outcomes divided by total number of outcomes to get the answer for this case. Now here we have to select 2 blue marbles and total there are 4 blue marbles. So this can be done in 4C 2 ways, that is selection of 2 blue marbles out of total 4 blue marbles. Then we need to have 1 green marble and total we have 2 green marbles. So 1 green out of 2 green marbles can be selected in 2C 1 ways. And similarly 1 yellow marble has to be picked up out of total 3 yellow marbles and that can be done in 3C 1 ways. So 2 blue marbles can be selected in 4C 2 ways, 1 green marble can be selected in 2C 1 ways and 1 yellow marble can be selected in 3C 1 ways. And all these 3 have to be done together. So we need to go for principle of multiplication, that is 4C2 into 2C1 into 3C1 divided by the total number of outcomes. Now total number of outcomes here is nothing but the number of ways in which 4 marbles can be selected out of the given number of marbles. We know that total number of marbles are 6 plus 4, 10 plus 2, 12 plus 3, 15. So we have to take the total number of outcomes as the number of ways in which 4 marbles can be selected out of 15 marbles. We know that selection of 4 marbles out of 15 can be done in 15C 4 ways. So the probability that we get 2 blue, 1 green and 1 yellow marble is nothing but 4C2 into 2C1 into 3C1 divided by 15C4. So by simplifying this, we can find out the required answer. But remember friends, in some cases the options are given in terms of NCR. So this itself can be taken as the answer. Otherwise, we need to go for further simplification to find out what is the correct answer. Let us here do the complete simplification and see what is the probability. 4C2 is nothing but 4 into 3 divided by 2 into 1. 2C1 will be equal to 2 and 3C1 is equal to 3. Divided by 15C4, that can be taken as 15 into 14 into 13 into 12 divided by 4 into 3 into 2 into 1. We are taking this based on the concept of NCR. We know that NCR is equal to n factorial divided by n minus r factorial into r factorial. We had learned this in case of permutations and combinations. So going by that, we can say 15C4 is 15 into 14 into 13 into 12 divided by 4 into 3 into 2 into 1. Now by simplifying this, we can get the required answer. So 2 and 2 here gets cancelled, 4 here goes 3 times, again 3 and 3 gets cancelled and 2 can be taken 7 times. So the final answer is 4 into 3 into 3 divided by 15 into 7 into 13. 15 into 7 into 13. Now 3 here can be taken 5 times. So this is 4 into 3, 12 divided by 5 into 7 is 35 and 35 into 13 can be taken as 455. So 12 by 455 is the final answer for this question. So depending on the options, either we can take this as the answer or we can simplify it further to get 12 by 455 as the answer. So this is how we can solve such questions based on combinations. You can see that probability here is nothing but number of favorable combinations by total number of combinations. Let us now take the second and third question based on the given data. Now again the data here says a box contains 6 red, 4 blue, 2 green and 3 yellow marbles. The second question says if 3 marbles are picked at random, what is the probability that all are red? So here we are selecting 3 marbles out of the given number of marbles and we need to find out the probability that all these 3 marbles are red. Now we know that probability here is nothing but number of favorable combinations by total number of combinations. Now favorable combinations here must be all 3 marbles to be red. Now we have got total 6 red marbles and if we want 3 red marbles we can select that in 6C 3 ways divided by total number of combinations is nothing but the number of ways in which 3 marbles can be selected out of the given lot. Here we have total 15 marbles. So the number of ways in which 3 marbles can be selected out of 15 is 15C3. So the answer for question number 2 here is 6C3 divided by 15C3. Likewise, the question may say that all 3 marbles have to be blue. So there we need to select all the 3 marbles from 4 blue marbles. So there the answer can be taken as 4C3 by 15C3. Or it can say that all 3 have to be yellow. So we can take it as 3C3 by 15C3. So depending on what type of marbles have to be selected, the questions on probability can be answered here. Let us now look at the next question. If 2 marbles are picked at random, what is the probability that both are yellow or both are green? So here we are selecting 2 marbles out of total 15 marbles. And we need to find out the probability that either both are yellow or both are green. Remember friends, whenever we use the word or in case of probability, it means plus. So we need to find out the probability of both yellow plus probability of both green. So probability of both yellow marbles plus probability of both green marbles. Please do not waste your time in writing down all these steps in the exam. Directly take down the required answer. Now both yellow marbles, we need to select 2 marbles such that both are yellow. Total we have got 3 yellow marbles. So this can be done in 3C 2 ways divided by total number of ways 15C2 plus we have got total 2 green marbles and we need to select 2 green marbles. So that can be done in 2C 2 ways divided by again 15C2. So this can be taken as 3C2 plus 2C2 divided by 15C2. 3C2 is nothing but 3 and 2C2 is 1 divided by 15C2 can be taken as 15 into 14 divided by 2. So this goes 7 times. So the answer here is 3 plus 4 divided by 15 into 7, 105. So 4 by 105 is the probability where both the marbles are yellow or both are green. The fourth question here is that if 2 marbles are picked at random, what is the probability that none is yellow? So here we need to select 2 marbles out of the total 15 marbles, but make sure that none of the 2 marbles is yellow in color. Now out of the total 15 marbles that we have, we know that 3 marbles are yellow in color. So while doing the selection of 2 marbles, we should not consider these 3 yellow marbles. Why? Because we need marbles which are not yellow in color. So these 3 should not be taken into consideration. That means we can select 2 marbles out of red or blue or green marbles. Now we have 6 red plus 4 blue plus 2 green. That is total 6 plus 4 plus 2 is 12. So out of these 12, we can take any 2 marbles and we'll see that there are no yellow marbles there. Why? Because yellow have not been considered. So we can say that the answer for this one is 12C2 divided by total number of selections is 15C2. So by simplifying this, we get the answer. So whenever we see that a number of marbles have to be selected in such a way that one particular color is not obtained, we simply leave those colored marbles in doing the required number of selections. So from the remaining 12, we have to select 2 marbles, which can be done in 12C2 ways, divided by total number of selections is 15C2. Why? Because total marbles are 15 and we have to select 2 of them. The question here is, if 3 marbles are picked at random, what is the probability that at least one is blue? Now here again we have a different condition. At least 1 marble out of the selected 3 marbles has to be blue. So let's see how can we get the answer for such a case. Now here we know that we are selecting 3 marbles. Out of 3 marbles, at least 1 has to be blue. So we can have various cases possible. That is 1 blue marble and 2 marbles of other colors, or 2 blue marbles and the 3rd marble of some other color, or all the 3 marbles can be blue. So we have total 3 cases here. So we can say that probability of taking 1 blue and 2 of other colors, or probability of 2 blue marbles and 1 marble of other color, or probability that all the three are blue marbles. So in all these three cases, we see that at least one marble is blue, one blue and two of other colors, or two blue and one of other color, or all the three are blue. We cannot go for more than three marbles. Why? Because total we are selecting only three marbles. So we have to find out the probability of each one of them and add them to get the required answer. Why? Because or always means plus. Now when we have to select one blue marble, we have total 4 choices. So one blue marble can be selected in 4C one ways. Into, now we need to take 2 marbles of any other color but not blue. Now if we leave these blue marbles, the remaining marbles are 6 plus 2, 8, 8 plus 3, 11. Now out of the remaining 11 marbles, we can select any 2 marbles. So that can be done in 11C 2 ways. Divided by total number of ways of selecting 3 marbles is 15C3. Why? Because total there are 15 marbles here. Let me repeat once again. We want 1 blue marble and 2 marbles of other colors. So 1 blue out of 4 blue can be taken in 4C one ways. And then we need 2 more marbles of other colors. Other colors here can be red or green or yellow. So total choices is 6 plus 2, 8, 8 plus 3, 11. So out of these 11 we can take any 2. So 4C1 into 11C2 is the number of favorable combinations, divided by total number of combinations is 15C3. Why? Because total we have got 15 marbles here and we need to select 3 out of them. Plus the second case, we have to take 2 blue marble and 1 other colored marble. Now 2 blue marbles can be selected in 4C 2 ways. Into 1 marble of other color can be taken in 11C one ways. Why? Because we know that there are 11 marbles of other colors, divided by total number of combinations is 15C3. Plus the last case, that is all the 3 marbles can be blue. Now all 3 blue can be done in 4C3 ways. Why? Because total we have got 4 blue marbles. So 4 we have to select 3, 4C3 divided by 15C3. And here we need not take any other marble. Why? Because we have already got the required number of marbles, that is 3. So when all 3 have to be blue, total number of blue marbles are 4. So 4C3 is the number of favorable combinations divided by 15C3 is the total number of combinations. So by simplifying this, we get the probability for the given question. So this is the direct way of solving a question where at least one marble of a particular color has to be selected. But we also have an indirect and a shortcut way of getting the answer for such questions. So let's see how to get the answer in an indirect method. We know that probability of success is equal to 1 minus probability of failure. So here, instead of taking the probability of at least one blue marble, we can take it as 1 minus probability of no blue marble. Why? Because at least one means there should be one blue marble or 2 or all the 3 have to be blue. So from total probability, if we subtract the probability of getting no blue marble, then we get the required answer. So instead of taking probability of at least one blue marble, we can take it as 1 minus probability of no blue marble. That means out of the 3 marbles that we have selected, there should not be any blue marble. So the answer here can be taken as 1 minus probability of no blue marble. Now here we are selecting 3 marbles and we need to take the probability that out of these 3 marbles there is no blue marble. So when we are selecting 3 marbles and we don't want any blue marble, we need to leave out these 4 blue marbles. So remaining marbles are 6 plus 2, 8, 8 plus 3, 11. So out of these 11 marbles, we need to take any 3. And in such a way, we get no blue marbles. Here it can be taken as 11C3 as the favorable combinations, divided by total number of combinations. Total number of combinations is nothing but selecting 3 out of all 15. That can be done in 15C3 ways. So this is the answer for this question. So either we can take the direct way of solving the question where we take 1 blue or 2 blue or 3 blue marbles. Otherwise, it can be taken as 1 minus probability of getting no blue marble. So simply remember that probability of at least 1 is nothing but 1 minus probability of none or probability of no blue marble. So either you solve it in this way or in this way, the answer remains the same. So this is how we can solve a 5 marks question from probability by taking it as number of favorable combinations by total number of combinations.